One of the really important resources that we will need to have when people are living on the moon is water. Now, it'd be nice if we could actually find water on the moon. So how do we go about looking for water? Well, we're going to do it with two robotic space probes, the Lunar Reconnaissance Orbiter, or LRO, and the Lunar Crater Observation and Sensing Satellite, or LCROSS. We'll talk about LRO first. The Lunar Reconnaissance Orbiter is going to go into orbit around the moon, and it's going to map the moon to finer detail than we've ever done before. As a matter of fact, if your coffee table were on the surface of the moon, LRO would probably be able to see it. But in addition to mapping the moon with this beautiful photographic camera, LRO is also going to look at the temperature environment on the moon, what are the high temperatures and the lows, and the radiation environment on the moon. These are all things that we will really want to know before we have people living on the surface of the moon. So the plan for LRO is that it will use its own propulsion system to enter into a circular orbit around the moon, a polar orbit going around the north and south poles, about 50 kilometers high. And from this, for 1 year, it will map the surface of the moon for what we call the Exploration Systems Mission Directorate, the people who are planning our future presence on the moon. After that 1 year mission, it will be turned over to the Science Mission Directorate at NASA, who will use it to do lunar science and study the history of the moon's surface, how it came to be the way it is. LCROSS is a very different concept. The LCROSS system consists of two main components. You have the Centaur upper stage of our moon rocket, which again, that has the motor that takes us out of Earth orbit and propels us toward the moon. And then later on, we will use that empty upper stage as our impactor. And then we also have the shepherding spacecraft. And this is what guides and targets that upper stage toward its target crater. And it also carries the scientific instrumentation on board that will measure and analyze the plume that we create. There's a range of instrumentation on board. We have cameras and we have spectrometers, both working in the visible and infrared wavelengths. Both LRO and LCROSS are scheduled to launch together in the spring of 2009. They will launch aboard an Atlas V rocket flying out of Cape Canaveral in Florida. As they launch and climb out of the Earth's atmosphere, we'll jettison or get rid of the lower stage of the Atlas V rocket, and it will fall back to Earth in the ocean. We will climb into Earth orbit, and after being there just a very brief time, fire the engine of the Centaur. The Centaur will take LRO and LCROSS out of Earth orbit and on its way toward the moon. About 2 hours after launch, LRO separates, and it will now take its own path to the moon to conduct its mission. 5 days after launch, LCROSS, still attached to that Centaur upper stage, will do a flyby of the moon, and will use the moon's gravity to fling us into a very highly tilted, highly inclined orbit around the entire Earth-Moon system. Each one of these big loops takes about 38 days. We call this an LCROSS orbit, Lunar Gravity Assist Lunar Return Orbit. The idea is that when we meet up with the moon again, we will do so that we're coming in at a very steep angle relative to the moon's pole. That upper stage, that Centaur upper stage, is going to hit at 2.5 kilometers per second, about 5,600 miles per hour. When it hits the floor of that crater, it will create a huge plume of debris arching maybe 10 kilometers or so into the moon's sky. LCROSS is going to be perfectly situated to be able to look down and see that impact. Over the next 4 minutes, the LCROSS shepherding spacecraft will actually fly down, descend through that plume of debris, sampling it and letting us know what it's made of. Is there in fact any water ice, and if so, how much? 4 minutes after the Centaur hits, the LCROSS shepherding spacecraft will also hit, creating a second plume of debris. That plume of debris, actually both plumes of debris, will be observed from the surface of the Earth through some of the greatest telescopes on the Earth, from telescopes in Earth orbit, such as possibly the Hubble Space Telescope, and from instruments in orbit around the Moon, such as the Lunar Reconnaissance Orbiter.